So, hello again. Welcome to another session. Tonight, we're going to discuss NASA's DART Double Asteroid Redirection Test. NASA launched this over a year ago, and it's going to go up there and smack something into a very small asteroid orbiting another asteroid and see if it changes anything. So we'll do that presentation, but first we'll do the news. So Artemis 1 is being waved off for its September 27th launch, and it's going to roll it back into the vehicle, the vertical assembly building. It's not their fault. Nothing went wrong. The latest wet dress rehearsal went kind of fine, if you ignore some of the leaks. But the reason why they have to roll it back is Tropical Storm Ian has Florida in its broadest forecast cone, and the gantry takes a couple of days to roll it, to disconnect it all, roll it back into the building, and then close the building. So they've got until Tuesday to do it. Scratch this 27th launch, roll it back into the building, and they'll probably attempt to launch in late October. But the good news is this gives Space Force the opportunity to refresh the launch termination system, the components that blow up the rocket should it go off course.
Yeah, those batteries.
It has to be a completely autonomous system that measures the tilt angle of the rocket. And as soon as the rocket goes off axis, you don't get a choice in the matter. There's no guy sitting on a button going, blow it up, blow it up. No, it blows itself up. It has to do that because what if you lose radio communications? So the detonation system has to be completely independent of whatever else the rocket is doing, which means it has to be battery operated. And the technology behind this dates back to the late 1960s. I'm guessing they're not, modern lithium-ion batteries. They're probably NiCads. They're going to roll it back, get it reprepped and certified, and then roll it back out and go, it's leaking again. It was very comical to see how they fixed the leak this time, because they were doing it via trial and error while they were doing the wet dress rehearsal. Okay, start filling it at full steam. They'd fill it up, and as they were filling it, it started leaking out hydrogen at more than 7% of what was going in was leaking out the connector. And they said, well, what are we going to do? Well, let's reduce the pressure a bit. So they reduced the pressure a bit, and it was still leaking out above the 4% tolerance level. So they reduced the pressure a little more, and it stopped leaking magically. That's because they were pumping less liquefied hydrogen through the plumbing, and therefore the plumbing was allowed to warm up slightly. And when you warm it up slightly from, 100 plus degrees below zero to maybe 80 degrees below zero, the metal expands and seals the gap. So they changed the pressure at which they will fill the tanks. So the tanks took longer to fill, but they finally got all the tanks filled up. It'll just take them longer every time they go to launch it. So that's Artemis. So we're going to talk about the DART program tonight, NASA colliding something with an asteroid. And much as they get into the me too, the James Webb Space Telescope will be pointed at the larger of the two asteroids to see what it can see. So you're obviously not going to see this kind of a picture from the James Webb Space Telescope. First and foremost, because the asteroid is so many millions of miles away and so small. And secondly, it's infrared only, so it'll look like just a big heat ball. But they're going to have everything. They're going to have the Hubble looking at it. They're going to have the Webb looking at it. They've got amateur astronomers looking at it. Everybody wants to see the big explosion, but there won't be a big explosion. If anything, there'll just be a little burst of light, and that's it. So now that the James Webb Space Telescope is doing science research and is up and cranking, it's taking pictures of whatever comes by. So they've got some pictures of Mars, as expected, because it's looking in infrared, and Mars is so close and so bright. You get what it looks like here on the right, the just big glowy heat maps. And then when you go to zoom up on it, everything looks out of focus because you're looking in infrared. Don't expect a lot from the detailed images of close-up things like Mars. Now, when you get out a little further, let's say, I don't know, Neptune. Neptune's pretty good because it has a ring pattern that they used to refer to as ring arcs, but apparently the ring arcs in infrared are full rings. Not only full rings, but the rings have structure. There's an outer narrow one, and you can see its moons are in the path of the ring structure, which if you remember with Saturn, it had small moons that were inside the rings, and they were referred to as shepherding moons because they would literally nudge the ice crystals closer together with their gravity, which caused the rings to get denser as the moons orbited. So it looks like there's two of the smaller moons of Neptune that are actually shepherding the rings. And also, speaking of the Webb, the first something's not working right has occurred on the Webb. There's like 19 different observing modes that the mid-infrared instrument can look at. And a couple of its modes involve a particular filter wheel. And the motor current on that filter wheel is saying, I'm having to push too hard. So the wheel wants to turn, but it's not being blocked. It's just seeing increased friction, and they don't know why yet. This is only for the grading wheel. The coronagraph and the regular filters are working fine. It's just the grading wheel. So they'll have to figure out what they're going to do. But this is the first, mechanical failure that they've had of the James Webb Space Telescope. Oh, the days of the big NASA rockets. Vandenberg is about to launch its final Delta IV Heavy rocket. And if you remember, the Delta IV Heavy is the rocket that they used to use to launch all of the truly deep space probes because it had, a center core and two side boosters, and the side boosters were solid rockets. So it could really kick heavy things up. And the Delta program, the Delta IV program, is going obsolete because it's not reusable. And if you pay SpaceX the right amount of money, they can launch things on a Falcon Heavy, and it costs a lot less money. So rather than building more Delta IVs, I guess they're going to be tossing SpaceX some money to launch all the heavy stuff. But Vandenberg's going to be launching its last Delta IV Heavy, and they're going to be launching a National Reconnaissance Office spy satellite, surveillance satellite, up to geosynchronous orbit. So a couple of weeks ago, we talked about the Mars InSight lander, got dirt on its solar cells, and it's not a rover, it's stuck in one place, so it has no ability to clear its solar cells to prevent it from dying of a freezing death because it can't keep its heaters running, because it can't generate enough electricity with its solar panels blocked. And lo and behold, it kind of came back to life. I guess the wind blew some of the dust off the solar panels, and they have to go back in and reevaluate it and give it another, so many months worth of expected lifespan. And turns out it's a good thing, because we've got another story that had a misnomer in it regarding Perseverance. People were talking about hearing meteorites hitting Mars, and they were thinking that Perseverance, because it has microphones, was what they picked it up with. No, they picked it up with InSight. The we're going to kill it any day now lander that doesn't move around, that had dirt on its solar panels. And if you listen to the sound of it, let's see.
NASA has recorded the sound of meteoroids hitting Mars. Here's a clip. Listen for what NASA calls the bloops. There, that sound, almost like bubbling water. The three bloops on the recording are when the meteoroid enters the atmosphere, then explodes into pieces, and then makes impact. If it all seems a little underwhelming, remember that things on Mars sound entirely different than they would on Earth due to differences in the atmosphere. A satellite orbiting Mars got pictures of the craters left behind as confirmation of the impact. The sound was recorded by NASA's Mars InSight lander after 3 years of trying. But now, scientists know what to listen for. Those little bloops.
So the shoo sound is the meteor coming in and getting some impact and friction, and then the bloops, I guess, are the sound of it hitting the ground. Okay, what do we have next? There was a Starlink mission with 54 satellites launched last Sunday, and then there's 52 satellites scheduled to have been launched this evening at 7:32. I didn't get a chance to see it. I'll watch it on replay. But that's like 100 plus satellites launched in 1 week. Somebody stated this week that there are now more Starlink satellites in orbit than there are satellites from all other companies that have launched satellites that are still up there ever, because they've got over 2,000 satellites up there, and no other company has that many satellites in orbit, not even the big military ones, the Boeings and the Grummans and such. And I found this one understandable, but distressing a bit. So I was reading the congressional act that established that UAP observing program that Congress had the National Security Agency and military set up. And in the text of it, they updated the text after it was released to say, and if it's something that we produced that we know about it, then we're not going to report it. And now this week, there was a a request, what do they call them? FOIA, Freedom of Information Act request. It was denied by the U.S. Navy. And the U.S. Navy says they're no longer going to be releasing any UFO videos that would harm national security. But they didn't really clarify what aspect of it would harm national security. Seems as though the UAPs might be us, our black projects, and it would harm national security if we release videos basically showing off our clandestine stuff.
Yeah, it's a big secret. Yeah.
So I guess they're going to go back to being secret again, except that's the government not releasing it. There's nothing about private groups with high technology equipment doing their own observation recordings and making those public until the men in black show up and tell them not to.
So we are going back to where we started, and they probably going to start to ridicularize people who go on TV, who saw things and started to destroy careers like they did for the last 50 years.
Hey, it worked for multiple decades. Let's go back to the old way of doing it. If it really is extraterrestrials and they're wanting to gradually drop their duck blind, then this posturing by the military won't really make a difference, because they'll probably just step it up, and instead of flying over places that the military has airspace control over, they would fly over more public locations, maybe lower, maybe slower. And then how would the military and the national security complex prevent you from seeing it if it's right there? It's right there, you know. So
they did that before. There was, if I'm not mistaken, Arizona, that like the whole city saw it, and everybody started calling the police and calling this and that, and people want to know, and they call the military base. And then at the end, people want to know an explanation from the government. And what the mayor did was just ridicularized. He bought like someone dressed in a a Martian suit and make fun of everyone. He lost the campaign because everybody was unhappy for him to making fun of everyone else. And then when you get ridicularized for something, nobody has the courage to say anything. It's like the whole city saw it. So they could just repeat what they've been doing so far. I don't think there will be disclosure or anything. They will ridicularize. They will make people lose their careers. They will knock doors and say, be quiet or you will disappear. And everything's going to go back the way it was.
Well, that particular incident before the mayor, our state senator or governor, I forget what he was, but he's not in office anymore, so that's good. The military at that time came out and said it was just flares. It was the Air Force on maneuvers, and they were just flares. All that means is if it's really extraterrestrials and they're really trying to show us that they're there, instead of flying a bunch of them in formation at several thousand feet, they'll just, bring in the big ship and let it hang in the sky at about 500 feet. How do you explain the way to that? When you can see detail on the surface of the craft. Yeah.
Lots of swamp gas.
Yeah. It's the light reflected off from Venus due to swamp gas. Yeah. And just to let you know, they're back doing it again. Fern Forest Nature Center has once again started their An Evening with the Stars public observing outreach. The problem is they've started it. They invited us. We were there. SFAA was there too. Les and Steve were there with scopes. That was the 4 scopes that were there. An individual brought their own refractor scope on a somewhat rickety mount. So it turned out to be good. The problem is the park has just started doing this and their calendar's out of date. So it says December 23rd. It's not going to be December 23rd. I think it's around December 4th. It's a very early Friday this year. And then you look up in the fine print and you see, oh yeah, this was last updated October 5th, 2021. So in 2021, it was December 23rd. But what they're putting out to the public is December 23rd with no year indicated here. You have to look up at the webpage last updated date. So
Are they going to do it again?
when I find when it's actually going to be, and it's expected to be early in December, then I'll send out an update. But I would not follow the December 23rd. So welcome once again, everyone. Tonight we're going to be talking about NASA's DART, Double Asteroid Redirection Test Mission. We're going to throw something at a small asteroid in the coming week and see what happens. So to use vernacular that is either scary as a government or sci-fi-y, it's all about planetary defense. There's many thousands of pieces of natural space debris out there, asteroids, comets. Comets actually approach faster with greater inertia than asteroids do, because asteroids are on smaller, closer to circular orbits, whereas comets are long looping orbits. So they come in from well outside and have had a lot of acceleration courtesy of the sun. So they're coming in much faster. Some of those will come close to the Earth within tens to hundreds to thousands of years. And the ones that stay away from the Earth, we don't care about those. The ones that come in really close to Earth, those are the ones that present a problem. The smallest of them, they'll probably be eliminated by the upper atmosphere. Either they'll be impacted by the density change in the Earth's atmosphere as they're coming in and blow themselves apart, or the heat of abrasion from the atmosphere, if they survive that, will heat them up to the point where they'll blow themselves apart. So not worried about the small stuff. There's tons of micrometeoroid dust that burn up per day, and nobody is the wiser because it's small and doesn't matter. So atmosphere protects us. The medium-sized ones are called the city killers, because if they did impact, they wouldn't end all life on the Earth, but they could take out a few blocks of a city. So you want to make sure you know where they're going to land if you can't stop them. The largest ones, and large is not enormous. Large is just a few hundred feet across is where it starts to get questionable. The large ones are considered planet killers or extinction level event sources. And they might end all known life on the planet. And if you don't think that's the case, just ask the dinosaurs. Oh, wait, you can't. Because they had an impact. So the Earth must be defended from the medium and large ones. I doubt that they'd ever let a medium one through just because it's only going to land in an unpopulated area because there are side effects. So the US government set up something called the Planetary Defense Coordination Office, the PDCO within NASA. And they're the ones responsible for going, find everything you can and defend us from it. So they're going to be looking for possible Earth impactors now and in the future. And they're supposed to come up with solutions to make it all better, kiss it, make it go away. So as they say in parimutuel wagering, you don't know your players without a program. There are comets, there are asteroids. They have different shapes of orbits, parabolic and hyperbolic. Circular is kind of rare, but some are. You need to know the sun orbit distance to know whether they're coming in slowly or quickly. And you need to know what's their potential for encountering the Earth. Are they near Earth objects or NEOs? NASA has a website devoted to just classifying all these things. So I pluck from it the ones that seem to be most concerning. And they give them acronyms. They're AMOs or AMORs, APOs or Apollos, HEEs or Acheans, and IEOs or interior Earth objects. And as you can see on the right, it's all about their orbital distance from the sun versus the orbital distance of the Earth. 1 AU is the distance the Earth is from the sun. So when you see something like, it's an interior Earth object, it is something that is at or just closer than the orbit of the Earth. So if it's going around when we're going around, our gravity could find it. So that's not good. And they further break all of these down into potentially hazardous objects. And they ballparked it at something that is going to be Earth crossing that is 5 million miles or closer than the Earth, to the Earth, and have a size of greater than or equal to 30 meters, about 100 feet, with an impact chance of greater than 1% over the next 50 years. So maybe in 50 years, we're going to have better defense mechanisms. But right now, they're shooting at find anything that's going to be approaching the Earth 5 million miles or closer that is 30 meters or larger, that has a 1% probability of impacting the Earth. Now, that impact probability is not really the impact probability, it's the unknown in the orbital characteristic. So you can have something that gets within 2 million miles of Earth, but is less than 30 meters in size, which the atmosphere will probably break up, so we don't care. But it can be 2 million miles, but we have such a good awareness of its orbit that we know it's going to be only like 1/10 of 1% over the next 50 years. So we ignore it and let it zoom by. So there's all sorts of factors. But how do we make it all better? How do we make it go away? Let's see. We don't have any repulsor beams, no tractor beams, no force shields. So I guess we have to do things the old school physics way. And the way you
For
do
now.
Yeah, the way you do that is you simply make a change to its orbit. You do something to it to change its orbit to the point where it's no longer going to be Earth impacting. Maybe it's just Earth crossing. So you change it from a hit to grazing by, less than geostationary orbit altitude, or a lot of times they're somewhere between the Earth and the Moon. That's plenty enough gap. You don't need to, blow it up completely into dust. For those that are familiar with Star Trek: The Next Generation, if you remember the phrase from Q when the comet was going to impact the planet, and they were asking him for assistance, what would you do? I just changed the gravitational constant of the universe. We don't have that ability. So here's how we would deal with it. Impactors, thrusters, ablators, attractors, or nuke them. So impactors, this is what we're trying out with DART. We're literally going to take something that has mass and collide it with a small asteroid and see if the asteroid changes its velocity or its orbital characteristics a little bit. Not a lot, just a little bit. We're not going to blow it up. We're just going to smack it. So if the asteroid is coming at the probe and the probe is going directly at it, the collision force will be not just the probe's force, but the force of the asteroid coming at it. So it's like a head-on collision. And those can be fairly powerful for very small objects. So we're just going to smack it a bit and see if its orbit around the larger asteroid changes by a detectable amount. Thrusters, I saw this one. We're going to land a craft on an asteroid, and the craft has rocket motors on it, and the rocket motors are going to point away from the asteroid, and when they launch the rocket, it's like a static test stand. It just pushes on the asteroid. So you might think about that for a moment. Sounds like a good idea. How many times have you watched different commercial entities and NASA do static test stand firings of some very powerful rockets? And you know what? Didn't change the velocity of the Earth any significant amount. In fact, the last time we changed the velocity of the Earth through something man-made was Saturn V launches. But the Earth recovered. It has enough mass that it recovered from that. So another one that I saw was ablators. If you take a laser, you put it on a spacecraft, you orbit kind of geostationary the spacecraft above a spot on the asteroid, and you beam the laser onto the surface of the asteroid and let it vaporize rock, the ejecta, the stuff coming off when you're heating up the rock, will act like a little tiny rocket motor and provide a push. But that takes a lot of laser power. And so far, the solar panels that we put up there to power spacecraft are on the orders of maybe dozens of kilowatts. So I can't see us powering up a gigawatt laser. And well, we could use RTGs, the radioisotope thermoelectric generators, but they're only good for a few dozen watts. So we would have to have a real fission reactor go up there and power this thing. And I can't see NASA launching one of those. The oops would be too big an issue. The most subtle one, though, I found is the attractor. You take a high mass spacecraft, the heaviest thing we can launch, and you park it. You don't make it a geostationary orbit. You make it an orbit with a certain velocity. So despite the fact that the asteroid might be rotating, it's always on the same side away from the Earth, so that that little bit of gravitational pull by the mass of the spacecraft over a long enough period of time, far enough distance, actually pulls the asteroid just far enough away to change its orbit. That one is probably the one that has the highest probability of working. The one that always looks good in science fiction movies, but not so good in reality, is nuke 'em. We'll send up a nuclear weapon and blow it all to hell. Yeah. But if it has a loose adhesion, suddenly one giant thing becomes lots of giant things. And heaven forbid that you nuke a rubble pile. A rubble pile goes from one giant thing to hundreds or thousands of things. And asteroids can be stony, metallic, or a mixture of stony and metallic. if it happens to be mostly dense metallic, mankind has yet to produce a nuclear weapon large enough to blow one of those things up. It would be like a giant ball of titanium and trying to vaporize it with a nuclear weapon. It might push it, but it's not going to vaporize it. And be careful of what you think you know until you figure out what it really is. So in 2020, we sent the OSIRIS-REx deep spacecraft to asteroid Bennu. We were thinking Bennu might have some surface debris on it, but it looks pretty solid. And then we did basically a touch and go. We had a probe come down and literally just scoop off the surface and bounce off and keep going. And now it's returning that sample. We went back and looked at the surface of it later. And what we found out was, gee, it's a rubble pile. Had it been a solid rock, we wouldn't have gotten a sample at all. But given that it was a rubble pile, we actually got a larger sample than we anticipated. It's like scooping up gravel. But had we attempted to do a dart kind of thing on Bennu, Bennu would have just like swelled up a bit and then came back together after a couple of years. So if it's a rubble pile, trying to impactor or nuke it is not going to work. But if you're not sure whether it's solid rock or a rubble pile until you hit it, you better not just have one mission. You better have like, try this, no, try that, no, try this, right in rapid succession. So what do all those solutions have in common? The presumption of time. We detect it far enough away that we can calculate its orbit precisely enough to go thumbs up or thumbs down. The way you do that is you have to do constant observations because these things could come in from the outer parts of our solar system, and we don't see them until they get close enough to us. The hard part is if we're observing from the Earth or in low Earth orbit, we can't see them if they're coming in from the direction of the sun until after they've already gone by. So we actually need spacecraft out beyond the orbit of the Earth looking back so it's not staring at the sun in order to see these ones that come in from the sun. We have to have enough time to create a plan to deal with the specific type of threat, be it metallic or stony or gravel pile or what is it? Need to figure that out. So we might have to actually send a probe to it years before it ever gets close enough to Earth to be a real threat. And then we have to have enough time to implement the design construction of whatever kind of spacecraft we're doing. We'll need a massive launch vehicle because we want to hit it or whatever we're going to do with it as far away from Earth as possible, which requires a big launch vehicle. So it's going to be a heavy craft and we want to get to the target fast. But remember, things are always moving around in space. Things orbit things. So we need enough time for the launch window alignment to get the shortest distance to the target. And much like we found out with OSIRIS-REx, it could take years to get from Earth to the target. And the farther out we want to deal with this thing, the better. Then there's the time required to affect the target. If it's a rubble pile and you smack it, it may take you a year or so before you figure out, oh, once the dust settles, it recoalesced. I'll explain this, but like they're doing with the DART mission. You do your thing, and then you come back a couple of years later and see what the effect is. And if we don't know upfront what kind of thing we're trying to get rid of, we may have to have multiple types of solutions in the queue, all wanting to go off at the same time. And try this, no, try that, until we finally mitigate it sufficiently. And if we only did it once, if we only throw up, we're going to nuke it, and then we find out it's metallic, is like, I'm sorry, there's no time for a alternative try. We don't want to be in that position. So the NASA Planetary Defense Coordination Office, they have an org chart. And if you look in the org chart, sort of just right of center, you'll find some of the names of the programs that have found things like Pan-STARRS, Atlas. You probably have heard of those. Those find comets and asteroids all the time, but they're under the observation management of the Planetary Defense Coordination Office. I think it's really just a money funnel to keep these things operating. The planet is not governed by NASA. There's other nations on the planet. So you'll notice over here on the right, there's a branch that goes out international. And there's IAWN, and then 2 other organizations. Those are the international outreach equivalents of NASA's PDCO. Now, what the PDCO has been tasked with is find 90% of the NEOs that are greater than 140 meters in size. Only 90? Wouldn't you want them to find 100? And identify the potentially hazardous ones. These are the ones that are within 5 million miles of Earth and greater than 30 meters across, with a 1% or greater chance of impacting the Earth over the next 50 years. The number of NEOs, near-Earth objects, we found so far is about 25,000. And this is from orbital gravitational calculations. And the 25,000, they believe, is about half of what's out there. And of that 50,000, maybe 10,000 of them are potentially hazardous. So they're going to have to be looking for a long time, better and better every time in order to find all of these. It's not the ones you know about, it's the ones you don't know about that are a threat. So if you take it international, there's the International Asteroid Warning Network, or IAWN. IAWN is not always big telescopes. Sometimes it's personal, better, larger telescopes. So they're personal scopes run by amateurs. So an amateur could find an asteroid that NASA missed. So you have to have this network, IAWN, to report new things that you find. But IAWN not only reports the hazardous ones, they report anything that will have a closest approach. Just remember, closest approach does not necessarily mean potentially hazardous if it's small or it's a known trajectory that's not close enough. But in the case of something coming in from the sun, none of these ground-based detectors are going to be able to see it. You need a space-based detector not in orbit of the Earth. Facing back the other direction, if it was at L2, would not be a good place either, because you're staring at the sun. What you want is orbiting in the Lagrange range, but not at one point. That way you can see in all directions, and you'll be on the other side of the sun. This is where we put the Solar Dynamics Observatory. So what is the DART mission? The DART mission is pick a target, make sure it's small because we're going to start off lightweight, and make sure that it is not currently a threat. And even if our impactor is 100% successful, that it's not going to change the asteroid to the point where it takes something that's not a threat and makes it a threat. So we're going to launch this craft. We've already launched it. We launched it in 2021. It has got solar panels, not nuclear, and it uses ion propulsion. So we get to test out the latest ion drive from NASA. The impactor has a camera on board, and we've actually used the camera already to see if it's working and to see that it points in the right direction. But it will capture images all the way until it go boom. But there's another CubeSat that was also on board that we've launched that will orbit the larger asteroid so it can see what happens when the impact occurs. So the camera on the impactor is called DRACO, the Didymos Reconnaissance and Asteroid Camera for Optical Navigation. I think they come up with the acronyms, then they figure out what the words should be. And the CubeSat is called Lycia, or Lycia, built by the Italian Space Agency, so it's an international effort. So the DART spacecraft was launched November 24th of 2021 from Vandenberg using a SpaceX Falcon 9. Now, by classifying it as a Falcon 9 and not a Falcon Heavy, that means the spacecraft wasn't all that heavy. But if we want to launch something that's going to be a sizable impactor, it would probably be a Falcon Heavy and not a Falcon 9. Target impact is Monday, September 26th at 7:14 p.m. Eastern Time. Oh, look, it's prime time. So you'll probably be able to see that on the NASA channel and other streaming sources. The goal of the impactor is not to blow up this smaller asteroid. It's just to basically nudge it a bit to see if we can measurably detect a difference in its orbit. Now, this is not its orbit around the sun. This is the smaller asteroid's orbit around the larger asteroid. That orbit typically takes around 11 hours, and they're looking for about a 10-minute change in the orbital duration. If it's successful, now they've got all of the physics that they need to understand how they can scale it up. So if it's successful, could be the basis of future missions for planetary defense. So these two asteroids, together as a pair, they're orbiting the sun. And the parent asteroid is Didymos. It's 2,560 feet across, or 780 meters. The smaller asteroid that is orbiting the parent is Dimorphos, and it's 530 feet, or as they like to say, it's roughly the size of, I don't know, Statue of Liberty, Empire State Building, pick something big. The smaller asteroid orbits Didymos about every 11 hours. That's DART's target. They're presuming that the target is not a rubble pile in order for the impactor to have a net effect. Remember, we didn't realize Bennu was a rubble pile until 2 years after we already did our grab and go mission. Goal is not to blow it apart. Goal is to have a measurable impact on its orbital period. So that's what the CubeSat will be calculating, is after effects of its orbital period change. 2 years later, the European Space Agency will launch the Hera spacecraft. It has 2 CubeSats plus the spacecraft. It's going to go back to Didymos. Notice it's not going to go back to Dimorphos. It's going to go back to Didymos. So these CubeSats will orbit the larger asteroid, and they'll do an assessment, because hopefully by then the dust of the impact from DART will have settled, and they will be able to take photographs and more precisely calculate the effect on the orbital period of Dimorphos international endeavor for planetary defense. So, in conclusion, the threat to Earth is real. Just ask the dinosaurs. Oh, you can't. We need far more observation programs looking for these threats. We require both Earth and space-based continuous observing. We currently have no proven means of dealing with any of these threats. Test solutions such as DART are required as test solutions. They're not an assurance. Let's give DART a try, see if it works, and hopefully Dimorphos is not a rubble pile. If it works as expected, fund larger scale readiness programs to get the solution ready, and maybe a couple of copies of them, because maybe you get a bunch of them all coming in at the same time. Yeah, we found 5 headed our way. We had just enough to take out 4 of them. Sorry, X. Game over. We currently have only one home. Its protection is essentially priceless. So don't go cheap when it comes to doing this kind of stuff. We need to be a multi-planet species in order to survive, because you never know what's going to take us out. Fund exploration programs to identify alternatives for mitigating these things. Fund self-sufficient colonization programs to spread the risk. So if we're going to go back to the moon, don't just go there as a tourist. Set up camp, set up a home, be self-sufficient as best as you can, because that's what we're going to rely upon should any of these things happen. And do advance the technology, because one day the sun's going to go bye-bye and Earth is going to go along with it, and we will need another home. And as usual, that's about me, and some hyperlinks on DART, the Planetary Defense Coordination Office, strangely enough, there's a lot of these deep space probes that are all operated by the Johns-Hopkins University Applied Physics Laboratory, and then the AIDA assessment program. And then thanks for watching.
Well done.
Thank you. Yes.
And it's not that so difficult. It's just because we didn't invest money just yet. But if you remember, if you get far enough to change the asteroid, it's easier than when it's close to.
Yeah.
So imagine like you have an angle like this. For you to move that angle just a little bit from close, you need to move just a little bit, just a small angle. But then, as time goes by, the change is huge in space, in kilometers, because just a tiny little nudge here. When you get the angle is open, and then that's all we need is for a few kilometers away from the planet. Doesn't need to be much.
In the case
because
of
that's like it just a close shave, it's good enough. But for that, we need to invest in large telescopes, in infrared telescopes. We need to keep doing the science and invest the science, because we need to map the whole area of the solar system, and that doesn't guarantee us survival if some surprise comes from the Oort cloud or from interstellar space.
If
Yeah.
you saw Don't Look Up, that's not just the only threat. It's the leadership on what they believe and how they react.
yes, you have to have faith in science.
Don't Look Up, the movie. That's like an excellent simile.
Yeah.
Yes,
Yeah.
just ignore the man behind the curtain. Just ignore the thing coming in from space. Yeah. For asteroids, the upfront knowledge of its orbital characteristics is about 2 years.
Yeah.
For comets, it's going to be more like 5 years. So comets come in at a much higher speed. So if we spot them, a year before they're going to impact the Earth, it's like game over, because they're coming in too fast. We don't have anything that's going to change their trajectory sufficient. So hopefully comets will go by and will never be a problem.
You would think this is an important enough project. It should be international.
It is international.
It is.
It is international, but each government has its own program. The IAWN is the only collective international active program. The UN has a council that's pondering it, but not doing anything actively. IAWN is at least taking orbital data from wherever they get it, and doing some prognosticating and coming away with orbital calculations and communicating that to other groups like NASA.
And the other thing is that some of the telescopes that went to some of the Lagrange points and some of the other to map specific like galaxies, or they were telescopes that see in infrared, and they have coolant. But then they reused the telescope when the coolant ended, like code. They call it the code time of that telescope is to do the science that was projected for. But then before they fire everyone in the agency that takes care of that specific telescope, when it loses the coolant and now it's hot, but hot in space, it means that you can still see it in infrared, and it's not that totally hot for the saves, like it's colder as in space. And they used some of those telescopes to map the solar system to find for larger asteroids. So we kind of reuse some of the asteroids, but this is because some of the astronomers were kind of pleased. It's not just because we don't want to lose our jobs. It's like, let's use this now for something else. You invested so many billions to put this spacecraft in space. Let's use all the capacity of that spacecraft to do something else for the survival of the species. And basically, they start producing all those agents around 10 to 15 years ago. So it's recent that you actually having some money being really seriously invested on this because with the advent of the ubiquity of all the equipment that we have in your pockets, all the science that coming from developing those satellites, those telescopes, and they end up in our pockets. So they saw it that when you invest in some ideas to protect us from space and do like that, it actually gives money to, multinationals. And then they actually, okay, that's a good idea to invest in planetary safety. And also, some of the astronomers, like consciences, they don't want to contaminate the other planets we have in the solar system. We already contaminate and destroy this planet. Let's safeguard the other places. And then during the planetary protection areas, they do also to avoid to contaminate other planets, especially the planets, the moons or satellites that have water. So we're carefully not to contaminate Mars, not to contaminate Europa or Enceladus. So we are trying to kind of figure out how to do that. So this is part of the planetary protection, but this is secondary. The most important is like not go to the, same way that the dinosaurs went. But we need invest. And this that Monroe is doing is something that if the public doesn't know, when you put this in the Congress to be approved, to be funded, people go like, what is that for? That's silly. Let's cut the funding. So it's like this kind of service that we do in giving people to understand what we are doing with our taxpayer money. It's not just to find cool science. The science ends up in our pockets, and the science probably will save our lives.
When you look at what happened at the radio telescope at Arecibo, and then you look back on the history of Arecibo and you realize how many times Arecibo used its deep space radar to photograph in radar asteroids and comets. And it can't do that anymore. And they've tried doing that with the NASA Deep Space Network. And the problem is the Deep Space Network is so pretty much overbooked at this point that it can't spare time to do those kinds of observations. You need dedicated resources for planetary defense. Programs like Pan-STARRS, Atlas, you need those programs where, for an amateur to do this, like, well, I'd like to look at Jupiter tonight. Well, aren't you going to be looking for asteroids? No, not tonight. Well, that could be when the threatening one goes by and you miss it. So it's got to be dedicated, pretty much planet-wide, 24/7, always looking at as much of the sky as you can. And if you don't do it that way, you're going to miss something. So why the National Science Foundation would not spend money to keep Arecibo maintained is, well, they wanted to, fix the budget and not spend more for the new programs. So they took money away from Arecibo and wanted to shut it down anyway.
Especially because it's not a state, it's a basic colony, as a territory. And they don't want to invest anything in Puerto Rico.
Well,
I don't know why. Maybe racism
the international investment isn't really the case, because they took money from Arecibo. They took money from the telescope array in southwestern US, and they invested it in a new telescope in South America, but as a joint international partner. So it's not that they don't want to invest elsewhere. It's they don't want to invest in new programs, new money. They want to rob existing, well-established, mature programs that aren't changing the world every day and aren't in the news every day. They want to rob those programs of money for all the new toys they want to make. So we've got to realize that it's not a net fixed sum. It's a growing fixed sum, and will always be that. A space probe will run out of fuel and will no longer be usable. That's a waste of the space probe because now you've got to build something newer. Of course, the plus side is you get to build something newer. But if you consider whenever you put something up there, it should be up there as long as it lasts, not as long as you don't go ho-hum and cancel the funding. But, infrastructure is not something humans think about long term. Think about the number of roads and bridges that are in dire need of repair, and we just weren't going to fund them because as you build more and more roads and more bridges, it creates a backlog of continuing maintenance budget, and nobody wants to see that get bigger. What has to get bigger? It's like saying the telephone company doesn't want to maintain telephone lines anymore because they're doing so much with mobile. Well, Verizon's already kicked that bucket. They've said, what if we offer you fixed 4G or fixed 5G? Why do we need to have a wire going to your house anymore? Why do we need to run fiber to your house anymore? And you don't. So you're going to see a migration away from maintaining infrastructure to abandoning infrastructure. Well, you can't do that with planetary defense. You've always got to be making it more continuous from more angles, better every time. That's how you defend the planet. You can't defend it by going, we got DART in the news media and Ares is coming up in another couple of years. Okay, we got that news media cycle done. Let's cut the budget back.
But the effort seems to be fragmented.
It is. Planetary fragmented, nationally fragmented. I think it's a matter of if you can just get SpaceX to take away more of the launch programs that NASA would normally send out to Boeing and Grumman and Rockwell and places like that, then they're going to come. Then those commercial organizations are going to come back to the U.S. government and say, "Hey, I lost my moon lander revenue stream. Give me something else." Okay, well, we can go put you on space defense. We can, give you the billions you desire for your annual trough money. We'll put you on something that's meaningful instead of something that's duplicated and not as good. So there's an avenue for them if they were just wise enough to connect the dots.
And the other thing is that, just talking about the technical, is asteroids and comets that we see the pictures, they change a little bit the image to be visible. It's basic mapping of the emission and absorption. And then when we look at those pictures, we see those comets white and we see the asteroids white, but it's not. It's just the way they picture things so the human eyes can see better. But in space, they all are darker than asphalt. Asphalt, like pure dark asphalt, has a albedo of 6%. Those objects have an albedo of 3% or even lower. So they're like the blackest black you're gonna see. It's like you go on the internet and you see like this is the blackest paint someone ever made. That's about the color of asteroids and comet in space. So for you to find an asteroid that's with a backyard telescope, only if it's a biggie. Because the small ones, they're far away, they're totally invisible, even for the mountaintop telescopes. The only way for you to see those objects is radio telescopes, like large ones, because then you need the definition, or you need like a larger array or a larger dishes for you to see in radio because they're small objects. And the other way is infrared telescopes. And now they put the James Webb Space Telescope, and the Kepler's done. Some other telescopes they turn off because it's difficult. There is no more coolant. So you have a limited resources for you to see. And then one of the biggest telescopes that you have around, it is now mothballing. I don't get it. I don't get it at all. Why they're cutting, the money for Sophia just because they have the James Webb. Sophia is more versatile than the James Webb. James Webb can see farther away, but Sophia can see many places that other telescope cannot because it's movable. I just don't get it.
Well, the part you don't get is they don't want to go back to Congress and ask for more money for NASA programs. So what they're doing is, if they want to do something new, they have to cancel something old. And something old can already be existing and actively be producing good science, and it doesn't matter. If we don't hear about it in the news all the time, that's a target for removing the funding or canceling the program. And the little things like, it costs too much money to maintain the 747 since Boeing isn't going to be making them anymore. Okay, all of the design specs for the components are available. That's part of us acquiring them as a government plane. 3D metal printers exist. You can fabricate new part, whatever you need.
No, that is not necessary. When you go in a hangar, all the extra bits and pieces are there already. They have the whole budget for the pieces, some of the engines. I think they have 6 extra engines.
Yes.
The Whiting Pratt engines. I think they have 6 extra engines there in the hangar, looking like a cone on the ground. And they figure out how to do the maintenance of the mirror, that instead for you to send to France to be remirrored every 2 years, they figure out how to wash it, and then the remirroring is every 4 or 5 years. And because they bought the facility to actually mirroring, they don't need to send that to France anymore. They can do the mirroring in the facility. So basic, the budget for the airplane is just like the regular airplane maintenance. And
but that's not the point. The point is, the people that are making the decision don't know of the capabilities and value of Sophia. And since they've never heard of it, it's a target for them to take money from it.
Yeah,
and every
that's basic.
you have
Because it's a little cozy corner on NASA that nobody knows.
Yeah.
Jay, I see you moving stuff there. Do you have anything to show us today?
Hold on. I'll show you what I took this morning. Hold on a sec.
We see. Oh, okay. Now we see the sun. Oh, wow. That looks awesome.
So that was this morning, and I'll show you the zoom.
Oh. That was energetic.
Whoa.
Yeah, the sun has been really active. Very, very pleasantly surprised how active it's been.
Yeah. So just for those who are watching now, if you see on the plage is the clear area that you see in the surface of the sun. That is a solar spot that's very round on right at the edge of the plage. That would be the size of Earth. Now compare the size of Earth with that mass emission at the corner. It's like 10 Earth sizes. That's amazing.
Yeah. There's been a lot of surface activity and a lot of activity around the edge.
Yeah, normally the heavier ejecta will come up and come back down in a curved shape. So you see an actual loop. This one looks like it's coming straight off the sun. So it's probably got enough force that it's going to actually be a coronal mass ejection.
Yeah, that was kind of incredible. What kind of a hydrogen alpha telescope you have? Can you describe for people who are interested?
Yeah, that's a Coronado called the Solar Max 2. It's 60 millimeter. It's basically a refractor, but it's dedicated hydrogen alpha telescope. Coronado was purchased by Meade, but even though it still retains the Coronado name, it's a Meade telescope.
Which is now an Orion telescope.
Now I want to show you another picture. So let me get this one up.
Wow, that's beautiful. You can see.
So this one is false color, and it's inverted. And I tried to mirror a photo that was on the NASA APOD, the astrophotography of the day. I think it was on September 15th. And that thread, I forget how many kilometers. It was huge, that little structure there. And it's funny because I've been imaging the sun literally every day. It's so easy for me to roll out the scope. It's on wheelie bars, so I roll it out. I got a spot marked in the backyard. So the minute I put it on the spot, it's basically polar aligned. I'm imaging the sun in about 5 minutes. I only image for at most not even a half an hour because you're taking video. So I look to see, well, I always take the chip is small. So in order to get the full sun, I have to do a mosaic of 4 inches. So I start in the top left, right, left, top, bottom left, right, bottom. And then I can patch those together easily in Photoshop. And then what you have to do is overexpose the sun so the sun looks just like a pure white ball. And you continue to overexpose it, and you look around the edge, and that's how you see what I call the solar flaring. And if I see a nice flare, then I back it off so I get good contrast. I try to focus it. I'll take video, usually about 2,000 frames. It's shooting at 60 frames a second. It's under a minute. And then after I've shot the flare on the edge, I reduce the exposure down. So now I see the surface detail, because when you reduce the exposure, you lose the flare.
Mm-hmm.
And I focus surface detail and shoot that for 2,000 frames. And then I process each one separately and then literally copy the surface and paste it over the white disk of the sun. And that's how and then colorize it in Photoshop, because I'm shooting in black and white. And that's how you get the surface and the flaring. But this one I reversed. And as I say, this guy, it was on the APOD, and he had a whole somebody did a whole write-up on the thread, what they call this solar thread. And I forget, it was huge. It's like 3,000 kilometers, something like that. It was amazing. And I said, oh, wow, he shot that at the beginning of September. Let me look at my images. And sure enough, I captured it, but I didn't know what I was seeing. Sometimes you capture things. And it's like if I was shooting a galaxy and it happened to, one of the stars was going nova, I wouldn't know.
Yeah, and then you go back to your old data and surprise, I did that and I didn't know.
Yeah, but yeah, that's what I've been doing during the day. The weather here in Charleston is, for the last 2 months, it has been absolutely terrible weather for astronomy in terms of visual or deep space imaging. It's been raining most of the day. It's been cloudy all night, and but usually somehow during the day, all you need is a good clearing between some clouds. That's all it takes to grab some video, because planetary imaging is simple to capture. The software in terms of processing is free to process it, so you don't need a whole lot of time. And then this week it has been perfectly clear every day, not a cloud in the sky this week. It's just amazing how the weather's changed. And I'm imaging now. I'm sitting in the backyard. I've been imaging Andromeda for the last hour.
Oh, that's good.
I'll image. I'll probably be out into the wee hours, because what's nice now is later the Pleiades comes up followed by Orion, and that's always nice to image those objects.
Yeah,
Well, I can hear on your voice that you're enjoying after months and months of just clouds.
Yeah,
yeah. I think
Hi,
the two,
everybody.
I think the two hurricanes have sucked all the clouds out.
Is there a chance to ask some questions?
Sure.
I want to say hello to everybody. Glad to see you all again. One day I'll be able to use a video. Wow, I'll tell you something. I never expect to really grasp a lot of what gets said here, but and I'm not saying I don't ever grasp any of it, but tonight I'm completely fascinated by what Monroe was saying, and very ironically or coincidentally or whatever, Lee, when he was talking further back, mentioning about, you know, the procedure to try and bust up the asteroids, use the plain term. I am only a 5-year-old Trekkie. Okay, so I'm a baby Trekkie, let's put it that way. So I was thinking I was going to come in and ask, like, did they ever, because they have so many solutions, quote unquote, I mean, you know, on Star Trek, that I thought, when did they ever, you know, have a subject matter like this? And then, you know, Monroe goes and brings up Q, which is pretty fascinating. I mean, they were really, I mean, so ahead of their time, but and still are, I guess, in a way. But then the other thing I'm trying to understand is, I was very surprised when I heard Monroe say they had names.
Oh,
So
yeah.
it's like, how many are we aware of? How many asteroids are we aware of?
Many thousands.
Really? And they all
Yeah,
have names?
they're to the point where the way the naming works is, you start out with the year and whether they're a asteroid, planetoid, they get a P, and if they're known to be a comet, they get a C. And we've actually had ones that were initially planetoids that we discovered as they got closer to the sun, they're actually comets. So they changed designation. And what you'll find is a year and a number and a letter. And the number tells you the month they were discovered in. And then the letter says
Wow.
in which order, because in a single month, you might discover, you know, 4 or 5 asteroids. So you've got
Okay, so I just took
arbitrarily
a number. I only look at NEOs. So those are the ones that we mapped already, some of them, and the ones that close to Earth. So that will be the risk factor. I'm not talking about the asteroid belt or the Trojans in Jupiter or Saturn. I'm talking only the ones near to Earth. It is 29,000 asteroid and
Wow. Unbelievable.
But
It is scary, you know, it is. I mean, they're all pretty large, right? Well, not so, we don't know.
no,
How large?
the ones that we know of that we've cataloged, we understand their orbits. If their orbits are near Earth, but we don't expect them to cross Earth anytime soon, we don't categorize those as potentially hazardous objects, or PHOs. So you have NEOs, which are just the ones near us. There's many thousands of those. But then within that, there's the ones that are close enough and have a high enough probability that we need to keep an eye on them. Those are the potentially hazardous objects. And of those, there's thousands, just, you know, maybe a couple of thousand.
Wow.
But then within those, they're the ones that have the higher percentage or are larger, and those we pay special attention to. And those, when they get good orbits, we actually give them real names. So the International Astronomical Union and the Minor Planetary Center get together, and you'll see the year, letter, alphabet designation when they first start out. But then if they get popular and well-known and maybe a threat, they'll get some Greco-Roman name usually.
Yeah. So I never saw the movie Armageddon. Is that something I would kind of, you know, I know it's a movie around this topic though, right?
Well,
I don't know.
it is a movie. It is a movie about asteroid impacts of the Earth, but
Right.
And cowboys killing it. So it's
Yeah.
basically a cowboy movie in space.
Yeah,
well,
what happens, really?
not just cowboys, but
Miners.
oil rig driller cowboys.
Really?
Yeah, they were drilling holes in it and put a bomb in the
You
hole.
gotta drill the holes to plant the nukes. The
Yeah,
nukes go down inside, and once they get down far enough inside, you don't need as big a nuke, but you need them all. You can't have like you're missing one nuke.
they were drilling
Drill
3
the hole
holes.
far enough.
And the
I might
premise
have-
of the movie, if we actually
Yeah.
did that, we would have destroyed the whole planet.
Well, even in that
Is
movie,
it-
they focused so much on one of them that they forgot about the other one. And it was the
Yeah.
other one that destroyed all of the east coast of the U.S.
Oh, so there was destruction. They didn't stop everything from happening.
No, they got rid of the biggest one, but the second
Right.
biggest one, which is the like city killer size, it didn't
Yeah.
actually land in a city. It landed just offshore of the eastern seaboard, and the tidal wave went in 200 miles
Oh,
and wiped everything out.
I'm not. I won't be saying that. Changed my mind. So
Okay, so
What-
just to give you another number, we have asteroids about more than 1,000 meters. So 1 kilometer size asteroid.
Yeah.
If they're not 900, just the ones near Earth. I'm not talking about the surprise ones that come from far away. The ones that we know now, that's near to Earth, is 900 asteroids, about a kilometer size. Smaller than kilometer size, they have like a little bit, like the ones that, could kill like a huge city. It will be around 4,200. And the one that a little small, like smaller city killers, those about 5,000. And
Oh,
then you go, depending on the size, like the ones that would not cause any problem, maybe just nice meteor size rocks for us to look for. Those are 4,000. And the ones that could like a small community or something like that would be between 30 to 100 kilometers, or to 100 meter size, it will be 6,000. So the ones we have to worry about, the ones like 300 to 1,000 meters and bigger than 1,000 meters, that would be 5,000 near Earth objects.
Oh God. So let me understand. So we are attracting them because you wouldn't know all.
Most of them.
But okay. But what Monroe was detailing and reading is that we're not really. We are going to be working on some ways to prevent, the destruction of the Earth or whatever, or we're kind of really not. We are. We're not. You know what I mean?
Okay, the best way to categorize it is the Planetary Defense Coordination Office did not exist until the Chelyabinsk meteor impact. So
Which
in
was
other
what?
words, for decades, the old adage was there's fewer people looking out for stuff hitting the Earth than the number of employees at one McDonald's.
Yeah.
And as a result of the Chelyabinsk incident, and remember, Chelyabinsk actually blew up 75 miles up in the sky. So the big thing never hit the Earth. What hit the Earth is something that's about this big. So
When did that happen? I don't recognize the name. I can't say it.
It's the
5
one,
years
remember,
ago.
there was the first asteroid that was filmed because in Russia, everybody has dash cams
Yeah.
on their cars because of the corruption of people.
Right.
So you need to prove it everywhere. So
was
there's
Russia?
cameras
Uh-huh.
everywhere in the cars. So
Mhm.
when that asteroid fell off, it was near Christmas. And then we are actually observing the sky from another one that was coming between the geostationary and Earth. But then in the same weekend, I think it was like very close to Christmas, you have the surprise Chelyabinsk that came from the sun, so we cannot see because it's just during the daytime. Surprise! And that's the one that
Oh, boy.
exploded. And then the other one that we are actually observing obeyed all the dynamics of orbitational rules and went by. And so it was like a crazy because we have a close shave and a surprise one. And the surprise
boy.
one was kind of shocking, the Chelyabinsk meteorite, because when it hit the troposphere, where most of the oxygen that we breathe is, and then when it hit it, it broke apart. But the shock wave was the one that destroyed the city. It broke every glass.
It didn't
A lot of
destroy the
people got
city.
hurt because they saw the bright light and then, oh, that's pretty. And then the shock wave came and kaboom and broke glass everywhere. It was like, that was the
I probably
one that
heard
happened.
at the time.
And it was filmed. People could calculate the orbital, dynamics, because it was so many angles of people filming that arriving that they study the temperature, what the chemistry of it is like. It was totally filmed. It was amazing.
Wow, that is amazing.
The two things that stood out, which is I think why the U.S. Congress was willing to spend new money on it, is it came in from the sun angle, so we had no clue it was coming in. The second thing is the sonic shock wave was sufficient to break a lot of building glass, commercial building glass, and destroy older, less stable structures. And the recovery costs, somebody connected the dots and went, so how much did we pay for that last hurricane that came through here? What if that same kind of event was like 10 times worse and it hit a big American city? They'd go, oh, we'd be spending dozens of billions of dollars. And then somebody went, somebody go have Congress fund this.
So this is the other point that you get.
So now we do have more people looking at it, but there aren't enough people looking at it. There aren't enough instruments looking for them full time, not only on the Earth, but out in space, looking back in the direction where they're not staring into the sun. So we need all these programs to kick up gangbusters before we'll ever feel safe. Because remember, it's not the one you know about that isn't going to hit you. The one you don't know about that is going to hit you.
So here's this.
Oh, go ahead. Let me talk.
So here's this notification, April 13th, 2029. Asteroid Apophis, Apophis. It'll pass at a nominal distance of 19,662 miles from the Earth's surface. That's the moon distance of about 250,000 miles, and it's closer than many Earth orbiting satellites.
Yes, that is below geostationary orbit, which is about 24,000 miles. So 19,000 would be closer than geostationary.
So we know this. So what are they doing?
Nothing.
It's not going to hit.
I knew you were going to say that. So this is what I wanted to bring up. You kept saying they, and two things really. The they part, when you were referring to, how they don't want to fund new money, as you're putting it. So when did this inability or reluctance to bring in the new money begin? Because we know who the administration is now. So I'm trying to get a time frame on, when this kind of fell back. You know what I mean?
We don't need money for Apophis, even though it's going to come in below geostationary, because we've been observing Apophis for decades. It's recurring. So we've been observing Apophis for decades, and we have a lot of detailed information about its orbital characteristics. So we know it's going to be a flyby. That's not the thing you worry about. Like I said.
I mean the whole program you were talking about. You say they won't kind of really proceed and fund it. Who is the which is the they now? What?
The U.S. government is the one that is producing the most funding for it. And the European Space Agency is piggybacking a ride to assist the U.S. space program in doing the observations. But where they're coming up short on funding is the continuous, like holistic observing. They've got some token programs out there. They've got some full-time telescopes like Pan-STARRS, but not enough. You need more coverage. And when it comes down to mitigation programs, right now DART's the only game. There's no other program that's actively spending money to say, how do we do this? So if DART finds out that this tiny asteroid is actually a rubble pile, and the smaller they are, the higher the likelihood of them being a rubble pile. If it's a rubble pile, it's just going to go blip, bloom up a bit, and then over the 2-year period, coalesce back down, because that's the only gravity source nearby. And it's as if, you know, we hit it and did nothing. So if you don't know whether or not it's a rubble pile, you need to have something like Arecibo to shoot it with radar to know how dense it is. If you just take a photograph of it in infrared or in basic radio, you can't see what's inside of it. You can't see how hard it is. But if you shoot it with enough radar, the radar will bounce off of something solid, kind of like getting an X-ray. It bounces off your bones, goes through your tissue. So if
well,
we have
normally
the ability,
we calculate the density if those objects have satellites. Then you can calculate using Newton-Kepler equation to figure out orbit and the major axis.
In this particular case, we're presuming that this smaller asteroid, based upon its orbital characteristics around the larger asteroid, means it's high density. But since we have a rough guess as to its size, we don't know what the mass to size ratio is. So we don't have 100% calculation of density. Remember, we thought Bennu was a rock with just some gravel on the surface of it, and turns out to be it's just a giant rubble pile. So until you do these observations, you really don't know what you're coming up against.
Okay, so talking about the Apophis, the one that Jay just mentioned, before we didn't have the characteristics of the orbit that quite precise, because every time it goes near the moon or near the Earth, it changes a little bit because it's very close to Earth. So it's a very difficult calculation because every time it passes on Earth, it changes a little bit the orbit. So it is, it's going to pass now, and it is supposed to pass on April 13, 2029. That we thought a long time ago that was the date that was going to be the fireworks date. But now that we are precise the orbit dynamics and understanding that, now the provision is that during the pass of 2029. It's going to become a resonant with the orbit of the Earth. And then the calculations are jumping that probably it's going to hit Earth on the 2060 or 2068. So we already have one that has our name on it, just that we are trying to understand. And then this objective that we are doing with some of those asteroids that we're going to test right now, the day after tomorrow, just to learn, to see if we can change the Apophis a little bit farther. We cannot touch that just yet because we need to learn more to actually change. So there are many ideas. At least now we have more than 7 years to kind of, you know, because we thought we have only 7 years. But now we have a little bit more time, so we are doing that, and nobody knows, nobody talking about. It's like, what? We have something, and you know, and astronomers and astrophysicists have to beg the Congress to put money on it. And like, I don't get it.
See, this is what I'm trying to. That's what I wanted to pin it down to. What I'm learning tonight. Obviously, I didn't know all this. So, begging Congress. So, who, I'm going to say, if Monroe or you were in charge, you know, what would the approach be? They haven't asked, no one I mean, the Congress, the House,
Well,
particularly, is made up of people from all professions.
yes,
And who has to do the asking? How does it happen in this case?
the best way to describe it needs to get kicked off. The president has scientific advisors, and the president can go talk to Congress, but it's really a matter of there are too many people that don't know the science, don't understand the science in the general population, that if all of a sudden the US Congress, regardless of what administration, said,
Right.
we're going to give $20 billion to NASA for planetary defense. The first thing that would come to mind is, we're building nuclear weapons in space. No, that's not the thing. We want to defend the planet from the things on the outside coming our way.
Okay,
How
so
do you
people
how do you
like you
explain that?
and Helen,
How do you explain that to a general? How do you explain that to an undereducated general population?
right, it's got to get out there. I mean,
Yeah.
my background's PR and marketing, but, this is way over my head. But the thing is, there's got to be a way, is what I'm saying. I mean, because what you're sitting here discussing this, like, even I pretty much understood what you're saying. And it's very scary to a degree, but it's also the hopefulness if the word gets out and the money does come in. Hey, Bill, whatever number you just threw out there, in terms of what they're spending now, that's nothing.
Yes,
I mean, we have a lot of problems.
As the saying goes, it's
They need to
pocket
do
land.
Yeah, they're right. Good expression.
If you ever get a chance to watch the movie, it's not Armageddon, it's the other one, but that's the one where it wiped out.
Leah Theoni.
Yes, she was the lead actress in the movie, Taya Leone. If you look her up on IMDb,
all right.
you'll
I will
find
do
the
it.
movies that she was in, and this was one where she played a reporter. Yeah, that one was an Impactor, but that was one where they kept everything secret, and the military program to defeat it was a black project. So it had
Deep Impact.
Deep Impact, yes.
Thank
Impact
you.
is the other
Okay,
one.
I'm going to look that one up.
Yeah, I'd say Deep Impact before Armageddon, because that's the finality of it. In Deep Impact, literally, the billions they spent were spent incorrectly, and it couldn't defend the Earth, but it was a black project, so the general public was never made aware of it until it was
This is so
too
bad.
late.
This could become, God forbid, reality the way you're talking. That's
Yes,
really
it could be. It could be that right now there's an impactor that has our name on it, that the U.S. government has a black project where they might be spending $20 billion for a solution, but I guarantee you there's somebody in that program going, let's nuke them. Because that's the only tool they've got. If all you've got's a hammer, everything looks like a nail.
Something's got to be done. I mean, there's got to be a joint effort in terms of maybe clubs like this.
Yes, it's got to be a planetary-wide funded effort, and it's got to be a pinch out of every nation's budget to just throw so much money at it and throw so many different programs and approaches at it.
Yeah.
Something's got to stick.
Yeah. Other scientific efforts besides ours. Yeah.
Let me ask you sort of an overall umbrella type question. So if you were to choose, and I'm not being facetious or whatever word you want to use, definitely not being facetious, or controversial. If you were to choose between solving, quote unquote, solving, don't mind me, you know what I mean, climate control. I can't think of the right word right now. Climate, what is it? Climate change or whatever.
Yeah.
Versus this subject of tonight, what would you call the more important one? If you have only so much money. What? I know. I agree.
Both of them. We have the money. Both of them.
Well, that's true. We do have the money. Just bringing the attention.
It's not a matter of one or the other. We can
you're right.
at the same time.
No, you're right. So now the other thing, I'm sorry to have so many questions, but this really stirred up my brain. I'm glad. Because you mentioned, what's his name? Oh, don't mind me. Okay. The SpaceX Elon.
Yes.
You mentioned him. Now, I believe you were trying to say that the private industry continues to get involved, that will help this situation. Is that what you're saying?
Directly and indirectly. Directly, the thing that launched the DART probe for NASA was a Falcon 9 SpaceX launch vehicle. So they're already helping out. It was a SpaceX rocket. It was a SpaceX rocket that launched DART. So they're already doing their job. But if we need to launch something even heavier, there is a Falcon Heavy. And once, Starship is operational, there is a heavy booster that's going to be the biggest thing ever. So leave them go on their track. They're doing good. It's all the other tried and true corporate brands that you know from the space program, like the Boeing, Northrop, Rockwell, all those companies. As SpaceX starts to take on more of the lower cost regular space program stuff, those companies are going to be starving for a revenue stream. Give them the, defend the planet stuff, because they understand the physics. They understand the basic rocket technology. If you look at the SLS program, you'll find that it was really Congress that said, well, take all these pieces and glue them together and you got a rocket. There you go. Least money spent. That's the reason why they're having so many problems with SLS. They weren't allowed to build anything new.
So now that part, I just have two more quickies. With something to do with yeah. So now, look, tonight, candidly or frankly, a lot of stuff going on in my life, fun stuff. I had not heard about the DART program or the whole situation there. And what I would like to know is, was that well publicized to the public?
I don't know what's well publicized. You didn't know about it, but I knew about it. Helen knew about it.
And I do listen to a lot of news, I'll be honest. I'm a newsy, I'm a junkie. But
people that sort of stick their head in wherever they can find information, like myself, I'm well aware of it. But general population, do you see it on whatever your favorite TV channel program is? I'm sure on Tuesday morning you will. And you'll go, how long has this program been going on? Well, it took 2 years to get there, and it took maybe 5 years to develop it. So it's been around for 7 years.
You're saying that this has been in, don't laugh at me. Am I interested? Did I hear you say, that line, that this has been in flight for 2 years?
Yes.
You know what I mean? In flight?
In flight, yeah.
What? So this started that many years ago.
Well, it's a long distance. It's a long distance. They're using ion propulsion, which is not that powerful, but it works over a long period of time.
No, that's okay.
So
I just wondered,
that's why it took so long.
So I'd have to research, Google, Bing, whatever, to see if at the time that it was, went out space, if there were articles and maybe news clips.
There were. Yeah.
Oh, there were.
Yeah. Yeah, but they weren't well publicized, because it's just SpaceX making money off your tax dollars, and they shot something. Okay, done.
That's aggravating.
It was a one-day news story, I'm sure.
And by the way, you have to think about it. The day of the launch is just the middle of the mission, because let's think about the first time the scientists sit down on a table to talk about that is probably 20 years ago. They got it like, no, this is not time for this now. We remove the budget because we have more important things to launch. And then they start the project. What about now? Can we do that? And they go, okay, now it's time to do that. Now they put the project, they choose the object, and so it's basic. Like, for you to get something on the launch pad, it put it 10 years or so.
So in this particular instance, it was the Chelyabinsk incident, but there were some guys already working on it. So they literally got the money from Congress and started spending right away, which gave them, I think, only a 5-year prior to launch window. And they had to build everything off the shelf. That's why they spun out the CubeSat to Italy. Hey, while we're doing the rocket and the impactor and the camera and the ion propulsion, could you guys, come up with a CubeSat that we'll just attach on there and throw out, and you guys do that part.
Okay, so you're saying, so how can I anticipate?
If you Google, let me tell you. So there will be a presentation live on the I forgot the name. It's like they have telescopes, amateur telescopes looking all over the world, and they do like an online presentation. They do on YouTube and they do on Facebook, and you can follow them. They're gonna start maybe 2 or 3 hours before the impact, and they're gonna comment. They're gonna have people on it. So let me find the exact name, and I will give it to you.
You're looking for virtual telescope.
Yeah, virtual telescope. Yes.
Yeah, I know these things. I think if you're looking for a more well-rounded to the general population presentation, just go to NASA TV and look at the current channel, and they will have a live feed on it.
I forgot about the NASA TV.
Yeah,
So
it'll be on NASA TV because it's a NASA program, and it's going to be well publicized, and the scientific community is waiting with bated breath to see whether it's a rubble pile or not.
I just hope that some of the regular TV networks pick it up.
No, they won't. No.
They won't. Not even really.
No. You know why? There's no advertising money behind it.
I mean, but they have their show that's supposed to report the NISA. They report science news. I mean, I'll be looking for it. I will be searching it. Now, I went off and on the mute. Let me just one last question for Monroe, and then one for our astronomer that with the sun photos.
That's
but
Jay.
Monroe, but you mentioned Saturn and the velocity of the Earth moving, changing. Did they know that was going to happen before they sent up?
Oh yeah. In fact, they're counting on it. When the impactor hits the small asteroid, they've got a CubeSat that's monitoring from the large asteroid the orbital period of the small asteroid. When the impact occurs on the small asteroid, they're going to go back and recalculate the orbital period of the small asteroid. And out of an 11-hour orbital period of that small asteroid around the larger one, they're looking for about a 10-minute reduction in orbital period. So
are you talking about
just a little bit.
Does that mean the speed of the Earth? Speed of the Earth?
No. The large asteroid is orbiting the sun. The smaller asteroid is orbiting the larger asteroid. And it takes about 11 hours for that small asteroid to orbit the larger asteroid. Once they hit it, they're going to go back and reevaluate the orbital period of the small asteroid around the large one and see if the 11 hours is now 10 minutes shorter.
Because when you said the velocity of the Earth, those are the words I thought I heard. I thought you
No,
meant
the velocity of the Earth has nothing to do with it.
And now the question for Jay. Jay, the pictures were insane. I never seen anybody take pictures of the sun. So you said you did them in black and white and then colorized them? Is that what I?
Yes, it's you pick up more detail using a black and white camera, and then you just basically I bring it into Photoshop, and you know the fact of the matter is when you take images, whether it's deep space images or the sun, a lot of it is art. And so people sharpen the image, they might bring out a little bit extra red color, and it's really, you do it to make it pleasing for yourself. But in the case of the sun in particular, most people will not shoot in color. They shoot it in black and white, and then they colorize it. Because if you look through this particular solar telescope, the sun is a red ball. It's not orange.
Oh,
that's the way the alpha filter makes it look red.
The particular wavelength of light called hydrogen alpha is deeply red. So if you took a color camera and you shot it through a hydrogen alpha telescope, you're going to get a very dark red image. But there's not enough differentiation in brightness in the various levels of red for the human eye to pick out a lot of detail. So if you use a grayscale camera, which is not just black and white, every pixel has, maybe 16,000 levels of brightness or gray, and you shoot the image that way, now you can come back and see a lot more detail because we have a lot of differentiation between dark and light. And then you take all those gray levels and you remap them as colors. And now you have a pleasing image because it's in color, which we like. And at the same time, you have a high dynamic contrast. So you can see lots of fine detail.
Fascinating. And I cannot wait to see what they
Well,
what goes on there.
you don't have to watch it live. You can watch it later on NASA TV as a replay, or probably on YouTube. You can watch it as a replay. So, it's not like it's not like it's not like you're going to watch the explosion happen in real time, because there's a long time lag from where the explosion takes place to the impact takes place to get that data back to Earth. So if you shot one frame every 1/10 of a second, you might miss some things. So it's going to take, it might actually be better to watch it as a replay than to watch it live, because when you're watching it live, you're consuming bandwidth along with a million other people. So your video feed may be stuttery because NASA may not have enough bandwidth to accommodate all the people wanting to watch it live. So it might actually be better to watch it afterwards.
Well, that will be great. And I can't tell you how much I enjoyed this tonight. Thank you, Helen. I saw that. I got to go back and write it all down. I
Thank you very much, Eileen. It's nice to hear you on the air again.
Well, it was good. You're good people. Thank you. I'll go back off.
What you got, Jay?
Screen. I wanted to show her. Okay, so that's the image that's taken in black and white. Well, grayscale.
Yep.
So that's how I'm shooting the image in general.
Mm-hmm.
And then let me go back. And then this one here is how I colorize it.
Yep.
It's the same shot.
That's why I was fascinated to see the sun. The big yellow ball. I don't think I have ever seen it like that.
Actually, there's a lot more. There's a lot more detail than the scale of the picture is showing you. If you either zoom up the picture or you move your head closer to the display, look at the detail in those two spots next to each other. You can actually see individual lines of plasma flowing into the depressed area in the center.
It is beautiful, Jay.
Yeah.
Very, very amazing. Very skilled to do that.
If you get the right kind of telescope from a visual perspective, and you don't even have to have hydrogen alpha, you can watch sunspots with what they call a white light solar filter. If you get the right diameter telescope with the right focal length, and you look at a sunspot like that, you can actually see the plasma flowing in these lines into the center of the sunspot.
And then, so when you look at the solar spots, it's almost like you're seeing a pen or a well that goes like this.
Yep.
So in that pen, the area that's just a little bit dark, where you can see the lines going in, that's the umbra. And then the dark part that you see is the penumbra of the solar spot. And then if you imagine that that's dark or black on the sun, it's not really. It's just a contrast.
Right.
It's just like when you look at a lamp, you see everything else around the lamp darker. But if you turn off the lamp, then you can see a little bit more around if you put a cone on the lamp. So that's the same thing. Since the sun is so bright that the solar spots look black. But if you erased all the sun and left just the solar spots, you could see the light on Earth. They are very bright, just 2,000 degrees or so cooler than the higher surface. That's the difference.
We would do solar observing outreach with the public, and we describe sunspots as those are the cooler parts of the sun, and they're black because they're just the next darker thing down, and the filter literally makes them black. The threshold, the light coming through that is bright, you see. The light that's being blocked by the filter, anything below that filter's cutoff level is black.
So your eyes too, because it work on your eyes
right,
too.
It's contrast level. But the center of the sunspot we described as, it's cooler. Well, how much cooler is it? A couple of thousand degrees.
2,000 or so.
And when you tell them the corona of the sun is hotter than the surface of the sun, like, how does that? And we go, Well, there's some people that haven't figured it out yet. You know, we're trying to figure
We're
out,
still
is
studying
it,
that.
is it the electromagnetism of the sun that's kind of holding it in like a giant force field and causing it to heat up? It's like all we have are postulations at this point. We have guesses, but we know that the outer gaseous surface of the sun is over 1,000,000 degrees, and the actual surface material is only about 12,000 degrees, and the sunspots are about maybe 7,000 or 8,000 degrees. So yeah, the dark spots are cooler, but you're looking through 1,000,000 degrees to see them.
But that Zominje was beautiful. I loved to see that the detail. I like to see the lines in the umbra going down. Like you can actually see the magnetic lines actually affecting the board of the hole. Almost looks like a sinkhole, you know, just
Yes.
going down. It is really beautiful. I love to look those.
When people talk about you need the largest diameter telescope for a big light bucket, like, no, you're looking at the sun. It's the brightest thing in the sky. Jay has a 60 millimeter HA telescope. The telescope I used that looked best at the sun was a 90 millimeter telescope, but it had an f14 focal length on it, focal ratio. And if you caught a sunspot right on the limb of the sun, you could actually see a little indent from the sunspot. And if you looked at it straight on, you could see the lines of plasma flowing into the recessed area. Think of it as if something is cooler, it contracts. And it contracts, and it's something the diameter of the Earth or larger. Something that large dropping in temperature by a couple of thousand degrees causes a depression in the surface of the sun. And the plasma on the edges just literally flows into it.
So for those who are not used to metric, 60 millimeters is, let me see, I'm going to put it close to my face and see if it works. So basically that's the size of the
We
object.
cannot see the numbers on it.
So that's where my finger is. So that's how close it's from the
easiest way to do it is whatever the number in millimeters is, divide it by 25 and you'll get a rough approximation of inches. So take a quarter of it.
This is about, this size.
Yeah.
That's the size of the objective. So it's a little bit bigger than my binoculars objective. So it's pretty good. It's like very expensive one. 60 millimeters for 100 and alpha. It's
an
pricey
HA
one.
scope, the expensive part of an HA scope is not the diameter. The expensive part's on the back end, and the fact that you want an HA scope. They see you coming, sort of thing.
HA.
What kind of what is it? Is the prism or is the
It's an echelon. It's an echelon.
okay.
It's two pieces of glass that have different levels of reflectivity by less than 1% difference. So the light literally enters between the two pieces of glass. One piece of glass is fixed. One piece of glass is on a tilt mechanism. And depending upon the amount of separation at the wide end, the light bounces back and forth in there, kind of like a little laser beam, like the old Ruby lasers. And eventually the light will bounce and it'll get close enough that it'll actually come out the bottom. And that's how you tune it, aside from the ones that are pressure tuned. They're under gaseous pressure. But the original ones, literally, it was a reflected glass, and a reflected glass, it's of a different percentage, and the light would just travel between them, and you would have a crank knob that you move very, even a quarter of a turn was massive. A tenth of a turn would be normal. And as you continue to look at the sun, your telescope heats up, and the two glass plates get warm, and therefore their size changes.
The index of refraction changes a little bit.
The index of refraction changes just enough that as your telescope warms up from viewing the sun, you would adjust the echelon just a little bit, and as it heated up more, just a little bit more, so you would have to constantly monitor it.
What kind it is, Jay? What kind of
It's a Coronado 60 millimeter.
Yeah, Coronado.
No, but what kind is pressure tune or echelon?
It's an Etalon.
Now, the sad news about an echelon is The two pieces of reflective glass are coated with silver coating, and they're highly reflective, but the heat tends to degrade the coating over a period of time. So if you use it like every weekend, they're good for about 5 years. If you only use it every so often, you'll get 10 so years out of it, and you won't notice it, but it is gradually getting darker and darker and darker into the red. The glass,
Well,
the glass.
count on the clouds to save your hydrogen alpha, J.
Yes. The glass that's on the front of it is what is known as an ERF, an energy reduction filter. So all it is a piece of glass that is a piece of glass, which means it doesn't let ultraviolet through easily. And then on the backside, it has a coating that is painted at a certain thickness that knocks out more than 90% of the visible light bandwidth. So it reduces the UV coming in, which is safety for your eyes, and it reduces the infrared and other wavelengths coming in. And then the echelon at the bottom, you adjust to just let like 8 nanometer hydrogen alpha through. I don't own one, but I wish I did.
Me too.
I would get one that would be like, give me one of those 127 millimeter ones that has pressure tuned. But those are like $4,500, so not soon. It's going on in the background.
The software talks to you.
Yep. Well, it's in the dark, so you need to know because you don't like the display, being so bright.
That's
It keeps me company. The problem here, we have a few imagers in the club, but their idea of imaging is they'll set up at 7, and then by 10:30, 11, they're going home. And to like these last few nights, it's new moon. There's no moon up, and so you got to take advantage when you've got no moon.
Yep.
You got a whole night with no clouds.
So next week we will not have an online session. Helen and I are going to the wedding of one of my longtime friends. One of his sons is getting married. I'm sure Helen will take pictures. So that'll occupy our evening this coming Saturday. So we won't do an online session this coming Saturday. Anything else about tonight's presentation? Anything else about anything else?
Nope.
Thanks, everyone.
No,
And
Thank you. It was always interesting. I love to hear you guys.
Oh, we're a few minutes earlier. What a miracle.
Yes.
well, I knew I cranked it out quickly, and I knew it wouldn't have that many slides. And so, thanks, everyone, and we'll see you in 2 weeks.
Okay.
Enjoy your wedding.
Okay.
Take care.
Will do.
Bye-bye.
Bye-bye.